Hi, warm welcome to you, Sylvain. So he's going to walk us on, how he made a powerful cache system using Go. He's actually a full stack developer and passionate by development. He more precisely work on web development because it can show the developer the creativity. And he's the creator of cache system for Træfik called Souin. The cache system is compatible with any of the reverse proxy like Apache or Ninjas. Since the version of 1.1 which he's worked on, he already experimented a template creation for a marketplace that can be retrieved at a particular address. So with that, a very warm welcome to Selvin.
Thanks to you. So first, thanks to OSConf organizers to let me talk to you about my side project. And obviously, thanks to all of you who are listening and hope you're all doing well. So before diving into the subject, let me introduce myself and make myself promotion to you. My name is Sylvain. I'm from Lille in France. Then sorry for my baguette accent, but I try my best to speak as well as possible. I'm Træfik contributor. I'm also creator of the cache system we'll talk about, and you can find me on GitHub searching my tag Darkweek and Darkweek_dev for Twitter. So let's replace the context of why I started to dev using Golang and how I came to do it. As I said, I'm Træfik user since 1.4, contributor and helper. Then for those who doesn't know Træfik solution yet, it's a reverse proxy created to manage containers architectures, and its container first approach. It supports the hot detection deployment, the scaling. It load balances your request automatically using the weighted one Robin, and use only a specific port for all protocols. So Træfik manage for you the service resolution depending host in entry. Then it's the pivot point of your infrastructures. It's like Kong or Nginx for those who have already worked with them, but really simpler to configure and to set up. Another good point is the fact you can install it on your development environment instead of Kong, because Kong is too wait. And you can continue your work after that. Then, as you can hear me, I love to use Træfik, and I love this solution. But after a few months using this solution, there was an issue I was facing too. There wasn't any cache system internally to Træfik. Then all requests would have to resolve the associated service. Then it took many milliseconds to be done. And I searched after cache system solution, but nothing appeared to be as efficient as I wanted, or it was only POC, so it doesn't interested me. After many nights spent to look after that, I decided to create my first program in Go. The fact I was totally noob with this language, but it didn't scare me because I had a goal, and when you have a goal, you'll do your possible to achieve your goal in any way. And it's different to start learning a language with a concrete project instead of learning a language with a tutorial or something like that. So this project called Souin is actually in 1.4.4, and for the record, the release names are free beer names because I love to drink beers. And obviously, don't forget to leave a star to this project because I've got an oversized ego, and it makes me happy to view the Stargazers count growing. And for those who are using Varnish, there is an illustration to show you how Souin is versus varnish, and that's just for training, obviously. So let's see together how it's easy to set up through a demo. So I've got a repository, a folder, more precisely in my laptop, and I've got two different files: a configuration YAML file and a Docker Compose YAML file. If I try to show you what is defined in the configuration file, we define a default cache key and specify to Souin to listen on the HTTP port, and it will store the responses on a TTL, which is 10 seconds. Then after 10 seconds, the cache will be thrown in the bin. And if I show you the configuration for the Docker Compose, we have three services. The first one is Træfik. The second one is Who Am I? So it will show you some information about the container and some headers in it. And the third one is the Souin instance, and it works with that. This is the minimal configuration to make Souin working. And I didn't say we define a reverse proxy URL key to tell Souin to call the reverse proxy behind the Souin instance. So if I just type Docker and it creates Souin, Træfik, and Who Am I instances. And if I try to load the website, we can see it took 31 milliseconds. And if I refresh, it took 8 milliseconds. But as I'm streaming right now and other things, other processes are running on my laptop. It's a quite slower, but in production it's really really faster than that. And as you can see, we are adding a new header to the response called X from cache to tell Souin handle the request and served the response. So now let me explain how to build fast applications with Go and specify in my case what kind of Go features help me a lot. So first, I can't talk about Go features without mentioning the Go routine feature. If you don't know that, Go routine is basically a part of a thread which will run one task, one function detached from the main thread, and it will close if the main thread stops or if it reaches to the end of the function. In this example, we can see that a cost function will be delegated to another part of the thread to be more efficient, and because we don't need the result of this execution, we don't store in any variables the result. Then here the update cache eventually is really cost effective due to headers validation, RFC checks, and etc. And you can easily do concurrency with the Go keyword placed before the function declaration and before function usage. Then another big feature is the channel. We can wait in main thread for information or push data to the Go routine. And today we are Golang application without channels, and obviously Go routines doesn't exist, or it's really, really rare. And a channel is like a bridge between the main thread that instantiates the channel and the associated Go routine. And for example, I use the channel to treat the incoming request and be able to coalesce them if needed. And only when the response is available, I return it to the client. With that, I can manage multiple connections at the same time on different or same endpoints. And as a channel, as a type, we can define our own channel. Like here, we are defining a reverse response channel that can take the same type as input and output. And you can only pass and retrieve reverse proxy. And retrieve reverse proxy type or nil. And a little tip, don't forget to close your channels because it can cause a lack of performances and make some zombified thread. Then I was facing an issue that Go doesn't support generic types at the moment. It will support them when Go in the second version will be released. So we have to find some tricks to be able to pass a generic object as generic as possible to have more flexibility. The solution is to apply the dependency inversion principle to decoupling software modules, thanks to Wikipedia for this definition, and use interface instead of the implementation. So you won't pass directly your instance, but you'll tell the Go interpreter you will pass an interface instead. Then it's a little bit tricky to implement an interface in Go. And sometimes you can implement an interface under the hood without knowing you're implementing it because you have not any keywords like implement or any others. So in Souin, we have some providers to be able to let the user decide which kind of storage system should be used, depending the matched URL in the full version. Here, we are defining the type of each provider. Each provider defines same functions, the list keys, the get, set, delete, and init. And since the last version, you have the reset function to reset the data or any other actions you want to do. So to make generic objects, we can define an interface like the abstract provider interface and can be part of an abstract provider interface array, for example. After that, we can pass our Redis or our Ristretto provider. And as the two structures are implementing the interface, it won't crash. But in your IDE, you'll have the auto-completion for an abstract provider interface and not your real object instance. So the power of Souin compared to Varnish is the configuration part, which is simpler than the disgusting VCL for Varnish configuration language. Here you just have to define a YAML and it works like a charm. On the left, you can find the minimal configuration to be able to run a Souin instance. And on the other side, you have the full configuration for the full version containing Redis, etc. And in the last version, you have the support of Aldrich for distributed cache storage. Then, as it's YAML, you can use anchors. You can write scripts to create dynamically the configuration, and the most of all, the configuration supports the hot reload. Then you don't have to restart Souin if you change the configuration. But I plan to disable by default this feature in the future to avoid memory leak. And avoid a thread running in the background from the start. Then keep in mind that existing keys are always stored and available in your providers when you change the configuration, but you can use the API to purge that, but we will talk about it later in this talk. So as Træfik, Souin is container first designed to be compatible with as much as possible with existing systems. You can define a Docker compose YAML file for Souin exposing the needed port and map the configuration file path, and be sure the reverse proxy is in the same network than Souin instance to avoid the external request and save milliseconds. This is the configuration for working with Souin out of the box. There is an available KG module and a Træfik plugin, which will be released when they'll support plugins that use the unsafe library. Hope this day will arrive soon. I'm talking with them about an implementation to do that. So it was so funny to dev this part, but I was facing the most complex part. The first one was the RFC implementation. I took time to blow a little because the RFC caused some traumatisms. And support RFC rule is really good to face and fight the depression because you think you're done with that, but another rule comes and you have to rewrite parts of your code. The RFC for request for comments designs the semantics of the web and apps to homogenize and define the standards of your responses, your behavior, and don't let the creator be free about implementations, logical parts, and data processing. So here is an example with the RFC 7234. It's just the first page, and there are another 42 pages. So that was a pain to support that, but thanks to other developers that implemented it in the past, then I can take advantage of their existing work, like the cache control library from the Apache creator, and it's really good to see the community doing very excellent work in Go. So when you're implementing on RFC, you realize that just if-else conditions, and you can see in this example to manage cache control header, it's just condition after others to be able to test every cases. That's the same thing for the expire header to check if it had already expired or always good to be served, for example. Then another cool feature is the support for the request coalescing. That means when you get multiple requests at once on the same route with same context, you'll temporize all incoming requests and you'll request only once your backend then use the same response for all temporized requests. That's pretty cool to be because your backend service can be on cheaper server and couldn't handle all requests if it was on frontline. So thanks to Single Flight for providing a library that can be used to handle and coalesce requests. Then as Souin takes care of users and won't let them manage the cache through an API, it provides some endpoints and secures them with JWT authentication. At the moment, you can only list keys to avoid content leaking and purge cache for a resource or multiple by regex. So let's see together how it works and how I did it to make it as faster as possible without impacting the base cache system. First, the configuration about all the API endpoints are the following. You have to define the API block in the YAML file. Then you can override the main bus path, which is Souin API by default. At the moment, Souin supports only 2 APIs, but in the future, it will support more endpoints. For each endpoint, you can override the bus path, tell if it's enabled or not, and it falls by default. Then specifically for the security endpoint, you are allowed to define a secret and a list of users to be able to log in as these users. For the Souin endpoint, you can tell that you want to protect related routes behind the JWT security firewall. For the cache management, the default bus path is Souin, and you can send a GET request on the base endpoint to list stored keys, or send a purge request on an ID or a regex to purge it. So here are some examples about the results when you are sending a request on these endpoints. Okay. As you can see, the bus path route returns an array containing all keys stored in the provider, and on the full request, on the full request, you have for each provider each key is related, and the provider will be the key of the associated array. And the purge request return nothing, expect no content either, to tell you the cache is now purged.
So we have one quick question. Does Souin supports SSL too?
Yeah, it supports TLS, and for the demo, I didn't show it, but it supports it. So the security API, we have the bus path, which is authentication by default. The login request set an HTTP cookie if authentication is valid. Then the refresh endpoint returns new HTTP response, which tells that the previous cookie should be replaced by the new one. Then here is the result about that. And we have the refresh and the login path. But in your mind, you can tell okay, it sounds great, but I want to know how to cut this. So I will show you the magic under the carpet. Basically, I get the main bus path from the configuration if it doesn't exist. It will use the default value Souin API. Then after that, I load each endpoint using the initialize function, which take a provider and a configuration as parameters. if the endpoint is marked as enabled, I just create an HTTP handle func with and without trailing slash. And each endpoint have a property named handle request as the name specified to handle the incoming request. Then the path is built from the concatenation of the main bus path and the endpoint bus path, and the code is running at the Souin startup only, and it takes only some milliseconds to be executed. Then the last tricky part is the key management. I'm using Ristretto for the cache storage by default, and it doesn't have a function or property containing the list of stored keys. It stores only hashed keys. So I had to declare it out of the Ristretto library. I called it keysaver in the Souin code base. I didn't have inspiration to name it with another name, and because why not to name it like that? Then the keysaver is basically a Go routine, and all actions on it will be run inside it. Get and delete function are asynchronous, and with this approach, I don't have any problems with concurrency as I try to write something in the array while I'm reading it. And thanks to the rlock and runlock functions to ensure nothing can edit our list while we are accessing it. So after this very long technical part, we can now talk about the deployment system. The deployment is secured by Travis CI to avoid regression. Then GitHub Actions get back the lead to deploy only tagged version on master and full version branches. First, the workflow for deployment. Tests through Travis are launched. The artifacts are built, and the last steps is to upload artifacts on the tagged commit to be able to download the OS and Arch associated binary. So here is a diagram to try to represent the Travis CI setup. And here is the configuration file about it. So first, I tell Travis to boot with a Golang environment. Then I add the Docker dependency to be able to run required containers. Then it ensures the compliance with every system. Then I decided to not sending emails. And after this setup, Travis will run the make create network to add the associated network, then run the make build dev command to prepare the container to run as development mode. And after that, it will run the make validate, which will group the linter verification. After that, it will run the test to handle any regressions, and finally, so we check that the production mode can be built and won't crash to ensure the compliance with users that use the latest Docker image. And after that, once it's merged on master and tagged, the GitHub actions will be called, and two jobs will be run. The first one is a binary generation to create artifacts depending the OS and Arch. It retrieves the tag name, pulls the tag branch, require Docker dependency, and enable build system to be able to build Docker images. Then it tries to log in to the Docker hub using secrets and build the prod container. In the minimal version, we are using latest instead of the latest full tag. And as you can see, here is the result on the Docker Hub. Our image is tagged as latest and is ready to be pulled, and obviously it's tagged as latest full for the full version. Then the last step is the artifact generation and upload them to the GitHub release through the Go releaser action. In this example, we built for Linux, Windows, and macOS for each platform. And after that, we have our artifacts on the refilled release. Then here is my face when I release the new version. So just for those who want to see what is the power and performances of Souin, here are some metrics to view how many requests it can handle per second. It took around 35 seconds to serve each 101,000 requests. The max response time was 56 milliseconds, and the minimum was 0, but it took some micro or picoseconds, but rounded to 0 milliseconds. So it's not really right. And it's due to Ristretto powerful in combination with the asynchronous updates. So after all that, what's next in Souin? There will be fully support of Vary, but now it's on master and it has to be tested more deeper. So I don't release it now. And another big feature was the support to uncoalesceable requests, and it's now available on master. And I plan to support the cache statue, the new RFC for that, and obviously increase performances on the cache system. Then I plan to release a new stable version on the next week. And obviously, if you want to contribute, you're welcome. Then here are some cool another side projects. Smerch, which is the open source pentest oriented platform. So you can check it and contribute on it. And if you want to use Caddy, I made a platform. It's HTTPS.